Hello all, this is Anand Kumar again, and welcome to my video lecture series number 2 from the last class. I think from the last class we have seen the introduction about the interprocess communications, message passing methods and sharing the memory space. And in this class we'll just start with the last class recollection, and we'll just go with the in detailed manner representation of the message passing aspect. As I told you in the previous class, an operating system can implement both methods of communication. First, we will discuss the shared memory methods of communication and then message passing. The communication between processes using shared memory requires processes to share some variable, and it completely depends on how the programmer will implement it. As I told you in the previous class, this is the slide from the previous class. I am just starting with this slide, that is, one-way communication using shared memory can be imagined like this. Consider there is a process 1 and process 2 are executing simultaneously, and they share some resources or use some information from another process. Process 1 generates information about certain computations or resources being used and keeps it as a record in shared memory. When process 2 needs to use the shared information, it will check in the record stored in shared memory and take note of information generated by process 1 and act accordingly. Processes can use shared memory for extracting information as a record from another process, as well as for delivering any specific information to other process. Methods in interprocess communication. In interprocess communication, that is IPC, refers to a technique and methods that allow processes to exchange data and coordinate their activities. Since processes typically operate independently in multitasking environment, the IPC, what we call it as interprocess communication, is essential for them to communicate effectively without interfering with one another. There are several methods of IPC, each designed to suit different scenarios and requirements. These methods include shared memory, message spacing, message passing, semaphores, signals, etc. So, coming to the role of synchronization in IPC. In IPC, that is interprocess communication, synchronization is essential for controlling access to shared resources and guaranteeing that processes or process do not conflict with one another with another process. Data consistency is ensured and problems like race situations are avoided with proper synchronization. Coming to the advantages of IPC, the IPC enables processes to communicate with each other and share resources, leading to increased efficiency and flexibility. It facilitates the coordination between multiple processes, leading to better overall system performance, and it allows for creation of distributed systems that can span multiple computers or networks. It can be used to implement various synchronization and communication protocols such as semaphores, pipes, and sockets. So there is some major disadvantages, including the complexity as usual included in the IPC section. Coming to the disadvantages of the IPC, it increases system complexity. It means making it very harder to design, implement and debug. And it can introduce security vulnerabilities, as processes may able to access or modify data belonging to other processes. It requires careful management of system resources such as memory and CPU time. And to ensure that IPC operations do not degrade the overall system performance, it can lead to data inconsistencies if multiple processes try to access or modify the same data over the same time or at the same time. Overall, the advantages of IPC outweighs the disadvantages, as it is a necessary mechanism for most of the modern operating systems. It enables processes to work together and share resources in a flexible and efficient manner. However, care must be taken to design and implement IPC systems carefully in order to avoid potential security vulnerabilities and performance issues. Coming to the conclusion, that is what we are going to see in the IPC in the next class. I'll just give it a conclusion. IPC, that is what we call as interprocess communication, is a fundamental component of contemporary operating systems, and IPC allows processes to efficiently coordinate the operations, share resources and communicate. IPC is beneficial for developing adaptable and effective systems despite its complexity and possible security threats. And we'll see the remaining in the next class. In the next class, we'll just start with the term called something called as IPC communication. And thank you for listening. Thank you.